Good day, students. In this clip, we're going to be reviewing some problems on graphs of trig functions. So let's take a look at question number 1. So it says, give the amplitude and period of the graph. So we have this graph below. If you examine this closely, what kind of trig function does this look like? To do a real quick review, remember your sine function looks like an S. If it's positive, the sign goes up like this. That's one period. If it's negative, it goes in the other direction like this. And your cosine function looks like a cup. So one period of your cosine function, if it's positive cosine, looks something like this. So let's write this. This is positive sine, and the red one is negative sine. And then for this one, you see this cup orientation. That is the positive cosine. The positive cosine starts from the maximum. Okay? And the negative cosine starts from the minimum and goes in the opposite direction like that. So that is a negative cosine. Okay, let's take a look at this graph. What does this look like? This looks like the curve starting from the maximum. So this is a positive cosine function. Okay? Now it asks for the amplitude. The amplitude is a displacement from the center to the max or center to the min. Okay? So this is a central position. The midpoint from the tip from the maximum points to the minimum points. This is the central position. Center. And we have the maximum, which is where all the peaks stop at. This is the maximum displacement from the central position. And this is the minimum displacement. Okay? So we have our center, max, and min. Now note, the amplitude is not a displacement from the min to the max. It's a displacement from the center to the max or min. So I can either compute this distance from here to here, or I can compute this distance from here to here. Okay? So how many units displacement are there from the center to the maximum or from the center to the min? That will tell us what our amplitude is. And we can clearly see that it's 4. I kind of covered it up a little bit. So this is 4 units. Okay, so that's our amplitude. Now to calculate our period, there are different ways we can calculate our period. One complete cycle is a period. So we had the maximum here. From this maximum to the next maximum on this graph, that will be our complete period. So we can go from maximum to maximum. That length will tell you the period. Or you can go from minimum to minimum. That length will tell you the period also. Okay, so let's do from max to max. From max to max, we can clearly see that the length from this max to this max is 4 units. No, I'm sorry, it's 8 pi units. From here to here, it's 8 pi units. So the period is 8 pi. All right, so let's write this down. The amplitude we found before, from the center to the maximum, is 4 units. And the period from max to max is from 0 to 8 pi is 8 pi units long. So we can clearly see that our answer is option letter D. Okay, let's take a look at number 2. We are asked to sketch the graph of these 3 functions and basically say what their similarities and differences are. All right, so let's start with function number 1. We are going to be graphing 3 cosine functions. So let's start with the first one. But before we do that, let's write down the general form for the equation of trig functions. So we have y is equal to a cosine bracket b x minus h plus k. Okay, so that's what we're going to be using to generate the graph of this function. So let's start with the first one. We have y. I'm going to write this function in this format. Okay, The coefficient of cosine is 1, y equals 1 cosine. The coefficient of the x is 1, so we have bracket 1 times x minus h. Let's change the h to a 0, since we're not subtracting anything from the x, so x minus 0 plus 0. Okay, if you have just x by itself, nothing being added to it, you have 0 and 0 here. Okay, now let's determine what the new origin is, where our graph is going to be centered. New origin is going to be 0, 0. So we can see that our phase shift is 0 and our vertical shift is 0. Let's figure out what our period is. Our period is 2 pi over b. 2 pi over b. In this problem, b equals 1. So we have 2 pi equals our period. And that tells us that 4 ticks is going to be equal to 2 pi. Okay? If you notice in this calibration we are using degrees, so if we want to write this in degrees, we're going to have 4 ticks equals, pi is 180, so 2 pi is 360 degrees. Alright, so I think that's enough information to graph this function. Oh yeah, we also need our amplitude. Our amplitude is A. Amplitude is the absolute value of A, so we're going to be computing the absolute value of 1, which equals 1. Alright, now let's go ahead and graph the function. So we are starting from 0, 0, and our amplitude is 1, so let's graph a 1 here. That's how high our function is going to go, and then it's going to go as low as 1, like that. Okay, so 4 ticks is equal to 360 degrees, so let's go ahead and do our calibration. So we have 4 ticks is equal to 360. So we have, if we break 360 into 4, we'll end up with these 4 ticks here. 90, 180, 270, and 360. So we have 360 divided by 4 is 90 degrees. Alright, so let's go ahead and graph the cosine function. We know that the cosine looks like the cups, so let's graph that. I'll graph the first one in red. So we have, it starts from the maximum, goes to the center, minimum, center, and right back to the maximum. Okay, so that's what our cosine function looks like. Let's connect the dots. So first, just a sketch. So something like that, and it ends there. Okay, let's graph the second one. We have function number 1 graphed. Now let's graph function number 2. Let me do the entire thing in green. So function 2, let's write y equals cosine 4x in the general form right here. So it's going to be y equals 1 cosine. You notice that b is 4 now, so 4 times x minus, nothing is being subtracted from x, so 0. Nothing is being added to the entire function, so it's plus 0. Okay, let's find our new origin. New origin is going to be the opposite of the letter next to x, which is 0, and then the number that's been added or subtracted from this term, which is 0 also. Our period is going to be 2 pi, or let's use 360 this time. 360 and 2 pi are the same thing. So 360 over b is 4, so 360 over 4 is going to be equal to 90. Alright? And our, so that tells us that for our calibration, 4 ticks is equal to 90. Alright, how about our amplitude? Amplitude is the value of A. In this problem, we can clearly see that A is 1. That's the coefficient of cosine. So we have absolute value of 1 equals 1. So that's enough information to graph. Let's go ahead and graph the function. We're still graphing cosine. Let's do the first calibration. 4 tick marks equals 90, so we have to divide this 90-degree region into 4. So the quickest way to do it, we split it down the center like this into 2 halves, and then go on to split the halves you created into another set of halves. Okay, so split this down the center like this, and split that down the center like that. Okay? Alright, so we can graph it there. So starting from the max, we have max, center, min, center, max. That's one complete period. We can see that it is much smaller than the other one. It has a much compressed period. So we graph it like that, and that pattern basically continues for the entire region. Okay. All right. So that's our second function right there, function number 2. Now let's graph function 3 and see if we can make a comparison. So for function 3, we have y equals 4 cosine x. Now, let's write this function in this general format here. So we have y equals 4, that's now a, cosine. The coefficient of x is 1, x minus 0, plus 0, because nothing is being added or subtracted to the x, and nothing is being added to this whole term right here. Now let's find our new origin. New origin is 0, 0. Opposite of the number next to x is the x coordinate, and then the other number is the y coordinate. Our period is 2 pi over b, or we can use 360 is the same thing as 2 pi radians, 360 over b, which is 1. So that's going to give us 360 degrees. So that tells us that 4 ticks is equal to 360 degrees. Okay, so each tick will be 90 degrees. And lastly, we need our amplitude. Our amplitude is the value of absolute value of A. So absolute value of 4 is 4 units. So we're going to have a displacement of 4 units up and down from the central position. Okay. All right, we have all the information we need. Let's go ahead and graph it. Our maximum is going to be at 4 this time because of the amplitude of 4. And our minimum is going to be at negative 4. Calibration will be the same as the first graph we drew, function number 1. So 4 tick marks, 1, 2, 3, 4. 4 tick marks being equal to 360 degrees, as we can see here. We are still graphing our standard cosine function, so we start from the max, center, min, center, max, and then we connect the dots. Okay, so it goes like that, like that, like that, then like that. Okay. Okay, let's go ahead and compare the graphs, similarities and differences. So I can just title it comparisons. What do we notice here? Periods. The green one is 2, the red one is 1. So we notice that the first and the second one have the same amplitude. Okay, so functions 1 and 2 have the same amplitude of 1, right? It's obvious on the graph. What about functions 1 and 3? They have the same period, right? Another similarity, functions 1 and 3 have the same period. Is there a similarity that all 3 functions share? Absolutely, they all start from their individual maximums. Okay, the individual maxima. So functions 1, 2, and 3 start at their maximums. Okay, the maxima. Now let's take a look at another example. So for question number 3, we have to graph y equals tan 1/2 of x. I'm going to include vertical asymptotes in our sketch. Okay, so first of all, to know where the asymptotes are at, we need to express tan using the quotient identity. Okay, so we know that tan x is equal to sine x over cosine x. So cosine basically tells us where the asymptotes of tan is. And we also have to recall that the tan function at something like this, it goes from negative infinity to infinity at every period. All right? Okay, so now since we're looking at tan x, to graph tan 1/2 x, we graph cosine 1/2 x. Now, why do we graph cosine 1/2 x? Because that is the function that tells us the locations of the asymptotes. Anytime the denominator is 0 or cosine 1/2 x has a value of 0, the tan function has a vertical asymptote. Okay, so let's go ahead and graph that. So we have y is equal to cosine 1/2 x. Let's write it in the form that makes it easy for us to determine its components. So we have y is equal to 1 times cosine, factor out 1/2, times x minus 0 plus 0. Okay, now this is easy for us to find the relevant components. Let's find a new origin first. The new origin for our cosine function is 0, 0. Our period is 2 pi over b, and we can clearly see that b is 1/2. So we have 2 pi over 1/2. How do you divide 2 pi by 1/2? We're going to multiply the numerator by the reciprocal of the denominator, which is a fraction. That is the same thing as dividing, okay? So we have 2 pi times 2 over 1. We'll multiply it across. We have 4 pi. That's our period. So this tells us that 4 ticks will be equal to 4 pi. That's our calibration process. Okay, let's see, our amplitude here, although it's not useful for this graph, let's just state it. Our amplitude is the value of A, which is absolute value of A, which is 1. All right, so I'm going to sketch the cosine curve. All that we're doing is just basically using the cosine curve to determine where the asymptotes of our tan, of the related tan curve is located. All right, so that's our max and min. I will take that out momentarily. So that's a max and min. So let's go ahead and do the calibration. How do we calibrate our x-axis? We have 4 ticks. 1, 2, 3, 4 is going to be 4 pi. Okay, going the other direction. 1, 2, 3, 4. That will be negative 4 pi. All right. Now let's put our points for our cosine function. Remember, your cosine looks like the cups. So you start from the maximum for a positive cosine like that, okay? So let's start from the maximum. Center, next tick, center, next tick min, next tick center, next tick max, all right? Going in the other direction, center, minimum, center, max. Now I'm going to draw my cosine function, cosine curve using, you can use a dotted line to draw it. All right, so let's just make it a dotted line. You don't really have to draw your cosine curve because it's just telling us where the asymptotes are at. The only points I care about are the points where cosine has a value of 0. Because when cosine has a value of 0, you have a vertical asymptote for tan. So can you see where the vertical asymptotes are at? They are the roots of the cosine function, right? So here it hits 0. Let's indicate where they are located. We have an asymptote here, 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 and here. Okay, so let's graph the asymptotes. So the first one, second one, let's do that again. Second one, third one, and then we have the fourth asymptote. All right, and then we follow the general pattern that the tan function follows, as we illustrated earlier. It's kind of like it goes from negative infinity up to infinity for every period. So let's sketch what that looks like. So starting from the center, it's going to go to infinity, and then start from negative infinity to the center, from the center to infinity, and then from negative infinity back to the center. That pattern continues forever. Okay? So that's basically what your tan function looks like. From the left-hand side, it goes from negative infinity to the center, and then on the right side, from the center, it goes all the way to infinity, and then this one from the center towards infinity. Okay, so that's the graph. This is a graph of tan of 1/2 x. Okay, let's take a look at another example. All right, it says select the equations that could represent the graph below. Okay, so this is number 4. So this is a trig function that has been phase shifted either to the left or to the right. I want to consider a phase shift to the right here. That's the closest maximum. So let's draw our new y-axis somewhere over here. So the question now is, what kind of function is this? What kind of trig function starts from the maximum and starts to exhibit this periodic behavior? This is your cosine function. Okay, so we know that that's a cosine function. 1, 2, 3, 4, 5. We know the amplitude is 5. It's positive because it starts from the maximum. If it were negative cosine, it will start from the minimum. Now the phase shift is the number of units that it's shifted to the right. Okay, so it had a phase shift here. So the question is, how many units was it shifted to the right? Now let's look at our options. We have 2 possible candidates, either 2 pi over 3 or pi over 3. So what is the accurate phase shift here? Well, it has to be smaller than pi over 2. The only degree measure that's smaller than pi over 2 and bigger than 0 is pi over 3. So our phase shift is pi over 3. Okay? So now we have enough information to write down the first equation of our graph. Is going to be y equals, the amplitude is 5 cosine, 5 cosine. You notice all the options have a period of 1, so let's not bother about that. Let's just focus on the phase shift, x. Now if you shift pi over 3 units to the right, is that a plus or a minus pi over 3? It's, you do the opposite, right? So it's minus pi over 3. So you can clearly see that the first option is option letter C. Now, which other candidate could satisfy this equation? Okay, so I told you all in class that I will provide you with an identity that you will use to find another equivalent function with this graph. The co-function identity applicable to this problem is the identity that helps you express a cosine function as a sine function. Okay, so the identity that we're going to use is the co-function identity sine theta plus pi is equal to cosine theta. What does this mean? This means that if you have a sine function and you shifted pi units to the left, what you end up with is a cosine function. Okay? Alright, oh, slight mistake, this is wrong identity. I meant to say negative cosine. Negative cosine. So if you want to express cosine, use a negative cosine, all you do is basically shift the cosine function pi units to the left. Alright? So let me just show you what I'm talking about real quick. So if you have, let's say you have a cosine function, something like this. If you reflect it, it goes like that, and then when you shifted pi units to the left, you end up with what you started with. Alright, so there are a lot of co-function identities, but this is the one that's applicable to this problem. And on the test, I will provide you with the identity. Okay, so you have negative cosine is equal to that. Alright, so this function tells me if I want to express cosine as a negative cosine, I just have to add pi to the angle. Okay, so let's do that here to see the negative cosine equivalent of the result that we got. So it's going to look like this. Y equals negative 5 cosine. Now that I have changed my cosine to negative to compensate for that change, to have exactly the same function that I started with, I need to add pi to my angle. Okay? Alright, so to finish it off, we just put this over 1 times it by 3 top and bottom. And then we have, this becomes negative 5 cosine x minus, let's see, minus pi over 3 minus, let's write it out, minus pi over 3 plus 3 pi over 3. And then your final answer is going to be negative 5 cosine x plus 2 pi over 3. Alright, and we can clearly see that our answer is option letter B. Let's shift our attention to the next question. So it says, which of the following graphs accurately shows y equals negative 2 secant x? So we have 4 asymptotic trig functions, and they have their asymptotes are determined either by sine or cosine. Okay, so let's go over those real quick. The 4 asymptotic trig functions are tan, cotangent, secant, and cosecant. Okay, tangent is given by sine over cosine, which tells us that cosine determines its asymptote. Cotangent is given by cosine over sine. So sine basically determines where the asymptotes of cotangent is. Secant is given by 1 over cosine. So cosine determines where its asymptotes are, just like tan. Okay? And then cosecant is 1 over sine. So sine determines where the asymptotes of cosecant is, or are. Alright, now let's take a look at this option right here. The problem tells us that y is equal to negative 2 secant x. So the asymptotes of secant, since we know secant is 1 over cosine, the cosine function helps us to determine where the asymptotes are. But we have to be careful here, there's a negative. Okay, so we're going to be looking at the negative cosine. So what does a negative cosine function look like? Remember, the positive cosine is like a cup opening up, so the negative cosine is like a cup upside down. Alright? So the dotted line represents the function that helps to determine the location of the asymptotes. So if you look at this right here, this dotted line is negative cosine. This dotted line right here is positive cosine. Let's put, this is negative 2 cosine. This is 2 cosine. This dotted line here, you know what it is? It's like an S. This is a negative 2 sine, starting from the center. And this one right here is 2 sine. So which of these accurately helps us determine y equals 2 secant? Since secant, negative secant is dependent on negative cosine, this answer, option A, will be our correct answer because it accurately determines where our asymptotes are at, which is basically the points where negative cosine x hits the x-axis or has a value of 0. Alright, so there you have it. Okay, let's take a look at the next question. We asked to graph y equals tan x plus pi over 2. Alright, so to graph this, we just need to remember what the general appearance of the tan function looks like. Remember the tan, starting from the center, just heads to infinity at the asymptote to the right, and into negative infinity to the asymptote to the left, and exhibits the same behavior forever. Okay? So the function that exhibits that increase in behavior from the left asymptote to the right asymptote are option C or D or B. Okay, let me not circle that. That's not good. So I'm going to eliminate option A. Okay, this could be a cotangent or negative tan. So now we notice that there's a phase shift here, x plus pi over 2. What does that mean? If you have y is equal to tan times x plus pi over 2, what kind of phase shift is this? Plus pi over 2 means you shifted pi over 2 units to the left. Okay, so pi over 2 units shifted to the left in the left direction. Okay, so let's see which of these have engraphed pi over 2 units to the left. If none of them have meets that description, then D will be our final answer. Okay, so pi over 2 units to the left. We have 1, 2, well, we have 1, 2, 3, so this is where pi over 3 is right there in the center. And over here, 1, 2, 3, pi over 3 is right in the center. So which of them fits the description of a tan curve that's shifted pi over 2 units to the left? And we can clearly see that it's option letter C, because this value right here is pi over 2, and we've been shifted pi over 2 units to the left, which is represented by tan of x plus pi over 2. All right, let's take a look at the last question. It says, the graph of y equals cosecant x has the same set of asymptotes as which of the following graphs? So remember, if we express these ones using the appropriate identities, we can know where their asymptotes are located. Okay, so we know that y equals cosecant x can be expressed using the reciprocal identity as 1 over sine x. So if any of these functions has a sign in the denominator, we use a quotient or reciprocal identities, then that will be our correct answer. All right, so option A, y equals secant x is equal to, can be written as 1 over cosine x. Option B, y equals sine x, cannot be expressed using a quotient identity or the reciprocal identity, so we'll leave it alone. Y is equal to cosecant 2x is equal to 1 over sine 2x. And then last but not the least, y is equal to cotangent x is equal to, let's see, what is this again? It's cosine over sine x. Okay? So this one and this one, they both have a sign in the denominator, so we know it can be A or B. But which of them is the correct answer? Notice the original problem calls for there to be sine x in the denominator, but this has sine 2x, which is a problem, but this has sine x, and this is exactly what we want. So we know that option C is not an answer. Your final result is option letter D. This function and this function have exactly the same asymptotes. Okay? They don't look alike, but their asymptotes are identical. All right, so that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel so you can get updates to other cool clips such as this. And please post a comment to let me know what you think about this clip. More clips can be found on mathgoserve.com. Thanks again for watching, and have a wonderful day. Hey there, students. In this clip, we're going to be going over an example on special triangles. We're going to be dealing with a composite case where we have a triangle that is a combination of the two special triangles, the 30, 60, 90, and the 45, 45, 90 special triangles, okay? And that's illustrated in this figure here below. So the instructions are for us to find the values of x and y, right? So in order for us to do this problem, what we have to do is basically split this triangle into two separate triangles and then treat them independently, okay? Now, in order for us to be able to find the value of y, we need to find the length of this segment. Since we already have x taken, how about we call this segment A? And then we have to find the length of this segment. And how about we call this B, and then we can call this segment right here C. All right. So in order to find Y, we need to find A and B combined. All right, and then we have another triangle here. So let's go ahead and draw these two triangles separately. I'm just going to make a rough sketch on the right side. So let's say we have this is the 30, 60, 90 triangle. Let's put it right here. All right, let's focus on this one first. We need to find this portion. How long is this segment, this portion of Y right here, so that we can then shift our attention to B and then go from there, right? So how long is that portion? So this is 18. We know that the hypotenuse is 18. This is a 90-degree angle. This is 30. If this is 30, then this angle here must be 60 degrees. So this is a 30, 60, 90 triangle. This side is A, and this side here is C. It will be beneficial for us to find the measure of C, because in this other triangle we know the measure of no sides at all, and we need at least one side in order to be able to find the other sides using the special triangle. Alright, so let's find A and C in this triangle right here. Now before we do that, let's draw the base 30, 60, 90 triangle. I'm going to draw it on the side right here. Let's use a green marker. So this is the base 30, 60, 90 triangle. It's going to guide how I'm going to populate the denominators of the sides in a minute. So the base 30, 60, 90 triangle is as follows. Opposite, the bigger of the two angles that are not right is 60 degrees, and then opposite that side is √3. And then opposite the smallest angle, 30 degrees, is 1. And then opposite the hypotenuse is 2. Alright, this is the base 30, 60, 90 triangle. Okay, this is the model that we use to create the other one. So this is similar to this, is scaled up by a certain factor. Alright, so what I'm going to do is I'm going to set it up as follows. Underneath the 90-degree angle, the side opposite the 90-degree angle, I'm going to put a 2, because you notice that there's a 2 opposite the 90-degree angle in the base triangle. Opposite the side opposite the 60 degrees, I'm going to put it over √3. And then opposite the 30 degrees, I'm going to put it over 1. Alright, so let's find A and B. So let's start off by let's find A. Okay, so to find A, we're going to set the ratio that we are missing a side that we have a variable in with the ratio that has no variable at all, which is this ratio right here. Okay, so let's go ahead and set up the ratio and then solve. So we're going to have, let's see, A over √3 is equal to 18 over 2. Alright, so to get A isolated, we'll multiply both sides by √3 on the left and √3 on the right. And while doing that, we can also see here that these two divide out. Okay, so this √3 and √3 divide out, 1 and 1, and then we're left with A on the left side equals, now on the right side, 2 goes here 1, and then 2 goes here 9 times. So we have a side measure of A being equal to 9 √3. Okay, alright, now let's go ahead and find C. Find C. Alright, to find C, we're going to set up the ratio that involves C. C over 1 equals the ratio that we know the values of both sides, 18 over 2. 18 over 2. Alright, let's go ahead and solve for C. C over 1 is just C. 18 over 2 is 9. Okay, so we have C and A. Alright, so let me box them, and then I'm going to be putting them back into the triangle in a minute so we can know where we're at. So that's A, and then that's C. So let's scroll up. This portion right here, C is 9. So this portion here is 9, and then A is 9 √3. So this portion right here is 9 √3. Okay? Alright, now let's shift our attention to the second triangle. This is the 45, 45, 90 triangle. Let's go ahead and sketch it over here. We're treating them independently. So So let's see, 1, 2, 3, 4, 1, 2, 3, 4. All right, so there goes your third. Let's do that again. So we had 1, 2, 3, 4, 5. Let me put it right here so you can see that they're actually separated from one another, like that, like that. All right, so there goes the 45, 45, 90 triangle, this portion of this whole composite triangle. All right, so we have 45 here, and then this side is x, and then we agreed to call this side b, right? What is the measure of this side? It's c, but we already know what c is. What is the value of c? C from the other triangle we're able to determine is equal to 9. Okay? All right, now to solve this triangle for x and b, we're going to create our base triangle, the base model for the 45 and 45, 90 triangle. Let's put it on the side right here, and then it will guide how we can populate the denominators. All right, so I'm just going to draw a little base 45, 45, 90 triangle right here. Okay, and then we have, this is 45. This is 45 right here, and that's 45. Opposite the 45s, we have 1, so this is a 1, and this is a 1, and opposite the 90 degrees, we have root 2. All right, so there goes your base 45, 45, 90 triangle. All right, so what does that tell me here? The side opposite 45 is a 1, so 9 is going to be over 1, b is going to be over 1, and then the side opposite 90 degrees is root 2. Okay, so put this over root 2. All right, so this is what we get because the two triangles are similar. So let's start off by finding b. So let's find b. Find side b. To do that, we're going to set up the ratio that has a variable with the ratio that doesn't have any variables at all, which is 9 over 1. Set both of them equal to that, all right? So to find b, we're going to set the ratio of b over 1, all right? And then equals 9 over 1. b over 1 is just b, 9 over 1 is just 9, so there you have it. All right, so now let's find x. To find x, what we're going to do is set up the ratio x over root 2 is equal to 9 over 1. To get x isolated, we'll multiply both sides by root 2, root 2, root 2, and then these root 2's cancel out. The final answer, x, is going to be equal to 9 root 2. So those are the measures of the sides of the 45, 45, 90 triangle. Okay, so let's put that back in there. B turns out to be the same as C. B is 9. Let's put that there. So this portion right here is 9. And then X is 9 root 2. Is that what we got? Yes. X is 9 root 2. All right. All right, so the question asks us to find x and y. So we can see from this shape that x is equal to 9 root 2. And then y is actually a sum of this base of this 30, 60, 90 triangle and the base of this 45, 45, 90 triangle. So it's going to be the sum of these two combined. So that answer is going to be 9 plus 9 root 3. All right, so that's the measure of the sides of this composite. All right, let's take a look at question number 13. So in this question, it says which quadratic equation has roots -8 and -4. All right, so the easiest way to see which of these has these roots is to generate the equation of the quadratic that has -8 and 4 as roots, okay? So in order to do that, what we're going to do is start with the roots. X equals -8 and x equals 4. X equals -4, set both of them equal to 0, so we add 8 to both sides here. So we have x plus 8 equals 0. And then in this one, we add 4 to both sides, and we have x plus 4 equals 0. Now the reverse of the zero product property gives us x plus 8 times x plus 4 equals 0. So it looks as though we were we're doing the reverse process of solving a quadratic equation. Okay, so what we'll do here, we're going to distribute. So for this out, we have x squared plus 4x plus 8x, first outer inner and then last, plus 32 equals 0. And then we'll combine the middle terms. We'll have x squared plus 12x plus 32 equals 0. All right, so the question is, which of this equation matches with this? We can clearly see that option letter E is automatically a match, so that's good. So this is a multiple response question, so there could be more than one correct answer. All right, let's start with option A. Take a look at option A. We have x squared plus 5x minus 2 is equal to negative 7x minus 34. So we want to put this in standard form, okay? So to accomplish that, we'll just simply add 7x to both sides and also add 34 to both sides. So our final answer, when we combine these terms, is going to be x squared plus 12x, and you subtract these two plus 32 equals 0. All right, so that's the answer we have. And we can see that this clearly matches with the original equation. So option letter A is a match. All right, so since the equations match, that means these will also be the roots of this, okay? Now let's take a look at option B. Option B, we have x squared plus 5x equals 7x plus 32. So what do we do here? We place this in standard form just like this and see if we have a match, all right? So to do that, we'll subtract 7x from both sides and subtract 32 also. So subtract 7x and subtract 32. All right, so let's go ahead and do that. On the left side, we're going to have x squared. Combine 5x minus 7x will give us negative 2x. And then minus 32 is a constant, so we can combine it here. So we'll put it on the side, minus 32. On the right side equals 0. Does this match with that? Absolutely not. So question B, equation B does not have the roots of negative 4 and negative 8. Now let's shift our attention to option letter C. Option letter C is already in standard form. Let's go ahead and write it down again. We have x squared, so this is option C. We have x squared minus 12x plus 32 equals 0. Does this match with this? Absolutely not, because the 12 is negative and here is positive. Let's shift our attention to option D. We have x squared plus 32 equals 12x. What we're going to do is put this in standard form. So to accomplish that, we'll just subtract 12x from both sides. And then when we subtract 12x from the left side of our equation, we're going to have x squared. We can combine these two since they're unlike terms. X squared minus 12x plus 32 equals 0. Does this match with this equation? Absolutely not. So this does not have the roots of negative 8 and negative 4. Option E, we already talked about that before, that option E is a match. X squared plus 12x plus 32 equals 0 is a match, so it's good. Now let's shift our attention and focus on option letter F. So option letter F, we have 1 plus 32 over x squared equals negative 12 over x. Now first thing we're going to do is multiply both sides of our equation by x squared. The reason we're multiplying by x squared is because that's the LCD of the two denominators that are here. Okay, so if you multiply by the LCD, you always eliminate the denominator. Alright, so if we multiply by the LCD, we have x squared plus 32x squared over x squared equals negative 12x squared over x. So if we reduce this, we'll have x squared plus 32 equals, because these x squares divide out, they cancel out. X squared goes here 1, x squared goes here 1. And then x goes into x squared x times. So on the left side, we'll have minus 12x. Now what we'll do next is basically subtract, add 12x to both sides, so that it's going to be in standard form. So add 12x, and then add 12x. And then our final answer is going to be x squared plus 12x plus 32 equals 0. Now does this match this equation? The answer is yes. So option F is also a match. Alright, so our answers for this question, the equations with roots of -8 and -4 are A, E, and F. Alright, A, E, F are our solutions here. Alright, let's take a look at question 14. We're to select 3 rational expressions that are equal to one another. Alright, so let's inspect all of this right here. If you notice, some quadratic expressions repeat themselves. For example, x squared minus 11x plus 24 repeats itself once, twice, 4 times. And then we also have x squared minus 7x, x squared, yeah, that's the main one that repeats itself. Oh yeah, also x squared plus x minus 5x repeats itself. So let's go ahead and factor the trinomials, okay? So starting with option A, let's start with option A. For option A, we have x minus 4 divided by x minus 8 minus 12 over x squared minus 11x plus 24. So what we're going to do is we're going to factor this so that we can find the LCD of these two denominators, all right? So let's go ahead and factor that. So we're going to factor x squared minus 11x plus 24. All right, so we're going to make up the x, use the x game to factor this. AC is 24, and B is negative 11. Put that in a so what two numbers work here? Negative 8 and negative 3. Multiply to give you 24 and add to give you negative 11. So we have x squared minus 8x minus 3x plus 24. And then we divvy up the center, and we're going to factor by grouping, okay? So let's see what we can do here. So we have x times x minus 2 times 2 times 2 times x minus 3 times x plus 24 breaks down into 2 times 2 times 2 times 3. Alright, so from the first two, I can take out x. So I'm left with x minus 8. And then here I can take out negative 3. And I'm left with x minus 8 also. Alright, so the factored form is x minus 3 times x minus 8. Okay? So let's put that back into the equation. We're going to have x minus 4 over x minus 8 minus 12 over x minus 3 times x minus 8. Now, how do we find the LCD? This has an x minus 8 that has an x minus 8, so that's good. This has an x minus 3. This doesn't, so we have to insert an x minus 3 here on the bottom and the top. All right. And then we can combine the two fractions. We combine in this first term here, we're going to FOIL it out. So we will have, on the page, we're going to have x squared minus 4x minus 3x plus 12 minus this 12 over the denominator, which is x minus 3, x minus 8, x minus 3 times x minus 8. And then when you simplify this, you notice that these two add up to 0. And then our final answer is going to be equal to x squared minus 7x divided by x minus 3 times x minus 8. Okay, so that goes our first answer. All right, let's shift our attention to the B. So for the B, we have, what do we have? We have x squared minus 7x divided by x squared minus 11x plus 24. So let's go ahead and factor the denominator. But wait a minute, we have already factored x squared minus 11x plus 24 in question A. We know it's x minus 3 times x minus 8. So this is equal to x squared minus 7x over x minus 3 times x minus 8. Okay, so that goes the answer for that. And then for option letter C, for C we have x over x squared minus 64 times x squared plus x minus 56 over x minus 3. Alright, so what we're going to do, let's factor the denominator, this numerator here, the right numerator. Well, before we do that, let's factor this one here. So we have x divided by, to factor x squared minus 64, you square root the first and the last and add and subtract. So we have x minus 8 times x plus 8. All right, let me partition my workspace so you can see, you don't get confused. And then on the right side, times. Now let's go ahead and factor this right numerator here. So let's do that on the upper right corner. We have x squared plus x minus 56. Use the x game to factor this out. So AC is negative 56, and B is 1. 8 and negative 7 works here. So let's factor this. So we're going to have x squared plus 8x minus 7x minus 56. Going to factor by grouping here. So we'll have, what do we have here? We have, from these two, we can take out an x. So we have x times x plus 8. Then take out a negative 7 here, times x plus 8. So we have x plus 8 times x minus 7. All right, so that's the factored form. Let's put it here, x plus 8 times x minus 7. And then this divided by x minus 3. Okay, so what do we have in this situation? You see that the x plus 8 cancel out, and we're left with, to multiply the numerator, we have x squared minus 7x divided by x minus 8 times x minus 3. All right, so that goes another solution that we have. And if you notice, B, C, and A are all identical. Okay, so the question was, which rational expression are equal to one another? All right, let's shift our attention to option letter D. So option D, we have x squared minus 7x minus 24 over x squared minus 11x plus 24. We already know the factored form of the denominator, right? Because we factored it in letter A. It's x minus 3 times x minus 8. Now let's factor the numerator. Okay, so we want to factor x squared minus 7x minus 24. So you make your x game. So we have AC is negative 24, and B is negative 7. And what works here? So let's list all the factors of 24. So we have, what do we have for 24? 1 times 24 2 times 12, 3 times 8, 4, let's write about 4 times 6. Okay, so which of these pairs will yield 7 upon combination? Let's write this again. So 3 times 4, 3 times 8, and 4 times 6. I have a complete list. Okay, so none of these pairs will give us 7. So that means this is prime. All right. So for option D, we have the simplified form is x squared minus 7x minus 24 divided by, if we factor that, it's going to be x minus 3 times x minus 8. We already found that out. X minus 3, x minus 8. So does this match with the other ones? The answer is no. So this is not a match. Okay, it's not the same as the others. All right, let's take a look at option E. So for option E, we have what do we have for option E? We have a division problem for option E. We are to divide x over x squared minus 64. That divided by x squared plus x minus 56 over x minus 3. Okay, so to divide, you're going to multiply the first one by the reciprocal of the second. So this is going to be x over, if we factor the denominator, we'll have x plus 8, x minus 8. Division becomes a times, reciprocate this, you have x minus 3 over. If we factor this, we already know what the factored form is. Let's see, what was it? We did that in part C. Is x plus 8 times x minus 7. So it's x plus 8 times x minus 7. All right. And let's see, do we have anything canceling out here for option letter E? The answer is no. So our answer is going to be, for E, is going to be x times x. Oh, let's just expand it. When we expand it, we're going to have x squared minus 3x divided by x plus 8 squared times x minus 8 times x minus 7. And this doesn't match the other two, so this is not an answer also. All right, lastly, let's take a look at option F. For option F, we have, let's see, for option F, we have an addition problem. So we're supposed to do x minus 4 over x minus 8 plus 12 divided by x squared minus 11x plus 24. All right, so we're going to have x minus 4 over x minus 8. So we need to factor this. We have already factored this one earlier in problem number, in letter D. We factored that. So let's go back and see what it was factored into. That's the denominator here. We also did it in B. It factors into x minus 3 and x minus 8. We also did it in A, x minus 3, x minus 8. All right, so let's put it in. We're going to have x minus 3 times x minus 8. Or x minus 8 times x minus 3, same thing. So multiply this side by what's missing here, which is x minus 3. X minus 3, x minus 3. When we expand it, this becomes, for the left side here, we're going to have x squared minus 4x minus 3x plus 12 divided by x minus 3 times x minus 8. So x minus 3 times x minus 8. And then when we simplify this whole thing, we'll have x squared minus 7x plus 24 over x minus 3 times x minus 8. Now, does this match with the other ones we have? The answer is no. So the ones that are equal to one another are options A, options C, and option B. Those are the ones that are identical. Option D isn't the same as the rest, so this is why we have a cross right here. It's not the same. And then option E is this form is not the same as the others, so that doesn't match, and neither does option F. So the only answers that occur